Hello, we are Team Organic Supplements, and this is our Project 2 Engineering 6 audio sampler. My name is Beatrice Tanlapco. I'm in section A03.
Hi, I'm Ira Sanchez. I'm in section A11.
My name is Eric Aroa, and I'm in section A05.
So what we have here are 9 load buttons, and once you press load, we'll bring up the file to open, and you can insert any WAV files and it'll save into this button. So right now I'm opening up 2. So when you press this, it'll play the song. And also for the second one. So what we have here are a pause, resume, and stop button. So for the pause button, it will basically pause our handle, which is our main handle audio we implemented on each button. So same goes for the resume and the stop. Over here, we also added a length to each of our songs. So for this song, it's 52 seconds, and for this one, it's 1 minute and 50. On our chop, you can edit the start and stop of what you want to chop. So you chop between 4 seconds and 9 seconds, and it will apply onto the audio file.
Alright. Next up, I'm going to be talking about the special effects that are on MATLAB. So I was in charge of doing sample reverse, delay, tone control, speed up, and voice removal. And so if I want to choose, let's say, the first file, I go to the first file. And we see it's Arthur. I'm going to pause it. And now I'm going to reverse it to show you guys how it works. And as you see here, it plays everything backwards to the duration of the length as well, so that's the change. And so basically for my code, I have instead of showing you guys how the speed of the reverse, I'll show you how delay works. So basically how I did delay is I got the object's value. So once to see if the checkbox was checked or not, so value is 1. So if the value equals 1, therefore you would get back the frequency and the sound back. And then once you did that, I actually added in a sequence of 10,000 to make sure that the duration would slow it down. My other effects are speed levels. So for speed levels, I did a pop-up menu, which basically each value was corresponding to like where the location was. So I did 3 different speed levels. So I did twice the speed, 3 times the speed, and 4 times the speed. So I did an if-else statement, so it would check to see what value it would do. And so we have the frequency multiplied by 2, the frequency multiplied by 3, and the frequency multiplied by 4. And so that was the same concept for tone control, where I did also a pop-up menu and just basically checked it for the same thing. And voice removal, instead of adding it back like I did for delay, I used to actually subtract the left from right sound, so that way the columns would make it shorter. So yeah, that's basically how my effects work.
So if you look at the interface, the GUI here, you notice that there's a keyboard here, which pretty much acts independently. And how it works is basically there's a duration, there's a text box there, and you specify how long you want the note to play. It's in seconds, so if you want it to play for, let's say, 3 seconds, you choose whichever note out of the 13 here. It goes from 1 octave to another octave. So we'll just hit C here. So that's a pure tone, C for 3 seconds, D flat. It goes up the scale basically. And they overlap as well, so let's say you do 10 for each and you hit C and then D, you'll play both notes at the same time. We also have a menu right here that specifies what kind of wave it actually is. So right here we were just giving an example of a sine wave, and we can change that to do sawtooth, which sounds a little bit different. A lot different actually. Square. Yeah, and the code in this acts pretty independently, like I said before. It interacts mainly with itself. So if we go all the way down here, basically for, let's see, yeah, so we'll just look at the button press for E flat. So basically we used the get function and used a bunch of handles and converted that to a double so that we can actually manipulate it with linspace. We got the frequencies from online. The frequency of this note is 311. And then, well, yeah, basically this part right here will actually play the note. This part right here is what plots the sine wave, as you can see here. Like, you know, there's a rectangle thing that plots, and then how the drop-down menu actually works are these if and else statements here. So what we did is we took the menu from over here, this square thing. We got the value from there and assigned it a numerical value, and then basically if the first option is chosen, so if 1 is chosen, then it's going to be a sine wave. If 2 is chosen, it's going to be a sawtooth wave, and if 3 is chosen, it's going to be a square wave. And it's pretty much the same thing. Right here we can see the piano menu. So we basically assigned piano stuff is equal to the cell, and we use the get function to get the string that's inputted there, and then from there we use another handle to assign handle's piano menu to the previous one. It's hard to explain code. And then basically this is pretty much the same thing for every single note. So D flat is identical. The only thing that changes here is the frequency. So yeah.
So now real quick, I'm going to show you the other effects on MATLAB. I'll load another file in, load Arthur, open, play. Alright, we see that it works, and now I will apply, let's see the speed. And as you see, it goes all crazy and speeds up accuracy.
That was the end. Thank you.